Today I will present our work on effects of knowledge and experience on privacy decision-making in connected autonomous vehicle scenarios. The second author, Iping, is my advisor. So connected autonomous vehicles, or CAVs, refer to vehicles that have both connectivity and autonomy. On one hand, CAVs use onboard sensors and other technologies to understand their surroundings, move, navigate, and behave without human inputs. On the other hand, CAVs can communicate and exchange information wirelessly with other vehicles, external network, and infrastructure. So the expected benefit of using CAVs is considerable, including road safety improvements, more efficient traffic management, and better driving experience for drivers. However, the massive data collection and use makes CAVs more prone to data exploitation than other privacy settings. While privacy-preserving technologies are under rapid development, such as pseudonymous communication and identity-based signature, relatively few works have been conducted to understand human aspects of CAV privacy. So among the few related works, USEC conducted a survey to understand drivers' prior experience to their acceptance of the CAVs. And intuitively, more prior experience leads to higher acceptance. USEC conducted an online survey to understand the public's privacy awareness of CAVs. And they find, well, participants could understand that CAV can use the data for image capture, object detections, etc., which they call primary use. They didn't believe that CAV can use the data for some of secondary use, such as recognition, identification, and tracking. So in other words, they're not fully aware of the privacy risks of data use in CAV. We know people regulate their privacy through dynamic process of perception, decision-making, and action selection. The lack of privacy awareness raises a series of interesting questions, such as how can we help users increase their privacy awareness, and how will increased privacy awareness impact the following decisions and action. So in this work, we made a new step in understanding people's privacy decisions in CAV. We also investigate a few factors to check their impact in CAV settings. So first, we know people's privacy decisions as context-dependent. Therefore, we propose different CAV scenarios to understand their impact in the CAV settings. And next, previous studies find people can be primed to think about their privacy through answering privacy statement. Moreover, feedback has been shown to encourage participants to develop accurate mental models and make informed privacy decisions. Thus, we apply these two manipulations and examine its influence to privacy perception and decision. Finally, we include experience as a measured variable to see its influence. So these are 4 research questions we want to ask through this work. First, will drivers' benefit perception and privacy risk perception vary across different CAV scenarios? And based on the benefit risk trade-off, what's their final data sharing decision? And next, how much will priming and feedback influence their privacy perception and decision? And finally, will experience matters? So we conducted an online survey to answer the above-mentioned research question. There were 3 between-subject conditions: control, priming, and feedback. Each condition has 3 phases. In phase 1, we provided a brief description of CAV. All the participants were asked to read the description carefully and then answer 3 questions. The questions were used to ensure all the participants have a basic understanding of CAVs. So those who participants need to correctly answer 2 questions to proceed. Those who failed will stop there and get the basic payment. So below is the questions we asked for connectivity. And phase 2 is the main part of our experiments. Participants will read 8 CAV scenarios in a random order. 4 scenarios are for convenience, and the other 4 are for safety or security. So below shows the example scenarios for safety. We highlighted the data types used and the purpose in each scenario. All the participants will answer 3 questions after they reading each scenario. The first one is benefit risk trade-off, with options listed in 5-point scales from less benefit than risk to greater benefit than risk. Second question is their data sharing decisions. That is whether they wanted to share the data to use the function. And the last one is their confidence ratings about the data sharing decision. In addition, there will be an extra questions in priming and feedback conditions where we ask participants to select all possible inference from the collected data. So this question serves as a way to prime the participants. And moreover, those in the feedback conditions will see their performance after they submit the answer. Finally, in phase 3, we will measure their general privacy concern with IU-IPC questions and collect their demographic data and prior experience with connectivity functions and driving assistance functions and their acceptance to CAVs. So participants that have used neither, either, or both functions will be labeled as participants with little, some, or much experience. Finally, we have 381 participants in our results, and we recruit them in Amazon Mechanical Turk, and all participants were in the United States, at least 18 years old, and have a valid driving license when they're doing the survey. So our participants is typical M Turkers. They have balanced gender, most Caucasian, and slightly higher educational level, and most importantly, they have adequate driving experience. So due to time limitation, I will only cover the major findings in our paper. Please refer to our paper to see more details. So first, let's look at the benefit risk trade-off results. Here, x-axis denotes the 3 conditions, and y-axis shows the mean values for each conditions in each type of scenario. And the error bars represent 2 standard errors. So definitely, the ratings is influenced by scenarios. Participants perceive more benefit in the safety scenarios. And only in safety scenarios, those are primed and provided feedbacks will have a lower ratings in the control condition. Next is the data sharing decisions. Here, y-axis is the percentage of participants that are willing to share their data. So we can find the main effect of scenarios is still significant. They more often choose to share the data in safety scenarios. And only in safety scenarios, those received feedbacks will become less willing to share their data. And notice that there's no significant influence of priming on their data sharing decision. So if we combine these 2 figures, we can find similar patterns. Now let's look at the experience influence to their privacy perception and decisions. By adding the experience, the only new significant term is the 2-way interaction of experience and the scenario purpose. So we change the axis to the experience level, little, some, and much. We can find only in the convenience scenarios, those with much experience perceive more benefit than those with some experience or little experience. And the same patterns can be found in their data sharing decisions. And such trends become less evident for safety scenarios, so only those with much experience will be more willing to share data than those with little experience. So based on the results, we have several findings. First, we found the purpose of CAV surveys is the most critical factors in our experiments. It has the largest effect size in our study. And next, priming itself is not enough. However, by providing feedback, the participants can have more knowledge about the possible inference from the collected data, and then make informed privacy decisions. We also confirmed prior experience matters, and it matters more in the convenience scenario. Finally, we noticed that in the CAV scenarios, people's data sharing rate is much higher than other privacy settings, such as IoT. So in our experiments, the overall data sharing rate is about 70%. And if we look at the similar study conducted by Jan Kopsa in 2019, the data sharing rate is less than 40%. And it holds even if we only consider the convenience scenarios. A possible explanation is that people perceive CAVs more from the perspective of vehicles than from a cyber-physical system. So such stereotypes may cause an underestimation of the potential privacy risks in the data use of CAVs. It also emphasizes the importance and uniqueness of human factors, of human aspects in CAV privacy. Our findings imply several recommendations to the privacy design of CAVs. So first, transparency on data collection purpose is essential for end users to make informed privacy decisions. We also recommend to equip users with knowledge such as the the possible inference of the collected data, and this can be done by the manufacturers. Finally, we suggest to consider the individual difference when designing the CV functions. Yeah, thank you for your attention. And I'm happy to answer questions in the panel discussion.